In the SA astronomical model, objects are physically on the firmament, and declination is a measurement of how far down or how far up they are. This is spread across from 90 degrees, being at the very top of the firmament, to negative 90 degrees, being at the bottom of the firmament. So right now we see that the sun, you can see in the left hand corner, if you load this model yourself or if you have a high def screen, go in full view, high resolution, you can see right now the sun has a declination of 22 degrees. Now if we manually adjust this ourselves and bring the declination higher, we can see that it goes up, 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 up on the firmament. It now has a 42 degrees declination. Now this isn't possible in real life. The declination of the sun stays between, it's like about 25 to negative 25. So if you see on the model here, I have it in red. So this just helps you as you're playing around with it. And as we lower the declination, see how the sun goes down, 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 and about 25 is the lowest point it goes to. Now, this model is accurate. So let me change the date. Let me go to May 22. So see how when I did that, the arrangement of all the planets changed? Let me just do that again in case you didn't see. So watch the planets in 3, 2, 1. See how they all moved? And you can also see the measurements too on both the left and right hand side. The accurate declinations are shown for all the planets in our solar system. So this is really a fascinating model. So we're right now on May 24th. So see this arrangement here? Let's go up into a globe-based astronomy software, go to May 24th, and look for the planets. So see this arrangement down here? We have the Sun, Venus, Jupiter, and let's also see if that's similar to what we have up here. So Venus, Jupiter, yeah, it might be hard to see in the far right-hand corner, but that's the arrangement. And then I guess Pluto is really close to the moon right now, and Neptune, or sorry, Saturn would be the next planet. So yeah, Saturn is right there, and then the moon is back there, and I think Pluto, they stopped showing it by default, but let me just see if it is. Yeah, it is between the moon and Saturn, just like how it should be on this model as well. Now the distance will be a little different because on the globe model they kind of reverse engineered it from the real life flat earth model. So this is what you're seeing right now is the equatorial grid. But what's important is that once you're above the horizon, everything is accurate. And the declination, for example, let me click on here. See how the declination for the moon is negative 28 degrees? If I go to the flat earth model here and look for the moon, negative 27 degrees. That's still very close. Now, it's hard to say which model is accurate and which model is reverse engineered. For example, on our model, we believe Polaris is exactly at the North Pole, or on the globe model, they have it like 1 degree off, like 89 point something degrees. So that's why I'm okay for my model here to show the moon has a declination of negative 27 degrees, and for the globe model to show it has negative 28. That confirms that what I'm talking about in my model is extremely accurate. And let's talk about Saturn here. Saturn has a declination of negative 6 degrees. On my model, negative 6.4. Let me zoom up so you can maybe see it better. Oh, cool. I should have done that from the start. You can't see the rest of, let me adjust that. So see negative 6.4? And then here, I don't know if I can zoom this up. Oh, sweet. Nice, nice, nice. So Saturn has a declination of negative 6. The moon has a declination of negative 28. And that matches the model here. So the moon declination, negative 27. Saturn -6. Let's check like Uranus. It should be about 18.4. Where is that here? Uranus. Yeah, 18.2. And the arrangement is what matters. We're going to have Venus, Jupiter, Uranus, Mercury. And then we see that here, Venus, Jupiter, Uranus, Mercury. So I have this table set up to sort in order by declination. And this is so let me just do something. If I go to 2023 and just do January 1st, see how everything's now changed? So Mars is at the top of the planet order now. So let's go to January 1st of 2023 in the globe model. January 1st. I go up like that. Okay, cool. And then Mars, we're expecting to be the first planet lined up. And yeah, it is. So Mars, Uranus, Jupiter, Saturn. How is that in my model? Mars, Uranus, Jupiter, Neptune. Hold on, let me go over here. Let me check. Where is Neptune? How is it if I type in Neptune? Oh, it just wasn't showing. Okay, so I might have to zoom up more to see it. Okay, so Jupiter, Neptune, and Saturn. So Jupiter, Neptune, Saturn. Okay, that's awesome. And then my model shows that Neptune should be at a -4 declination. And here we see it's, yeah, -3.5. So this is extremely accurate, and the arrangement you see on screen of the objects and planets is accurate. It might be hard to recognize the planets if you don't, like, for example, on the far right, that's Mars, the red one. Uranus is kind of this light blue one. Jupiter is that one kind of in the middle. Neptune is right next to it, that blue one. Saturn we got with the weird little ring picture. And right after that comes Mercury, which is this weird color one. And Venus and Pluto are actually hidden behind the sun. So let me adjust the sun's declination so you can see the hidden planets. Okay, cool. So now you see Venus and Pluto. And let's just confirm where Pluto is, and we should see Venus is the next planet right beside it. Yeah. So this model is accurate.